Okay, welcome everybody. I'm Michael Meelis, and I'm going to get to it. So I want to really get forward. Are you enjoying yourselves?
Yeah.
Yeah. I'm going to change that because you and me have all been breaking the law. And welcome to my courtyard. And this is a place where I will be the judge, the jury, and the executioner. Just because I can, because I'm the speaker. But who finds this very similar? It looks a bit similar, doesn't it? Who here grew up in the 90s watching bad comic movies, action movies with Sylvester Stallone and stuff like that? Yeah, here, come on, raise your hands. Yeah, come on. So, really, dig a bit. You remember this? It's a bit obscure. But if you see this, I am the law. And I'm going to be the law here, and I'm going to judge and see what we did and which laws we broke. So first, we have to analyze the laws that are there. So first off, that always comes to mind is Murphy's Law, right? Who hasn't been affected by Murphy's Law? If something goes wrong, you haven't been affected by it. Oh, okay. Because everybody is affected by it. But it's not per se a technical one. So let's do another one. It's Brooks' Law. And Brooks' Law was actually already mentioned, which I find very nice. It's with the mythical man month, which is actually referring to adding more people to a team. Yes, it will go faster, right? Right? No. So then we have Amdahl's Law. And I don't know if there are any software engineers, software architects. This is if you run software in parallel, then you expect it to go faster, but it won't. The more you do parallel, the slower it will go. So then we have Knut's optimization principle. It's a law principle kind of thing. So if you optimize prematurely, it is really like a death sentence. You should just make it and optimize later. Otherwise, you will just build up a whole load of code that you don't need. Then you have Moore's Law. I think one of the most famous one, and maybe for infra a bit more familiar, which is the compute power will double and double and double. And people keep on saying it won't happen, and still it keeps on happening. So I think it will stick there and will stay. And then the last one, but the Pareto principle, 80-20. And I want to focus a little bit more. So because like 80% of a company, right? Yeah, 80% of a company exists of what? Of engineers, of platform engineers or software developers or stuff like that. So if 80% of that is, then 20% is the problems that we cause. So I'm pointing at all of you guys here. But as a smart guy once told me, when I'm pointing my hand towards you like this, there's 4 fingers pointing back at me as well. So yes, I'm guilty of this as well. So let's go on. The most important law that we have broken and we keep on ignoring and we don't see is Conway's Law. And I'm so happy to see that a lot of people actually already know it and they raised their hands and showed it. So I will go quickly over it because I think some stuff has been said already in the past, is your architecture reflects your org chart. So if you build software and you start looking at it like, okay, how does this communicate? How does this converse with each other? And you put it against the org chart that you have, you will see that a lot of these things will be very similar because of the communication that you have. And the most important thing that Conway said is that the bandwidth of the communication needs to be very large. And the more managers and the more layers in your organization, it comes down and down. So, coming up to the second part, I'm going to be the jury. So, I've been talking about Conway's Law and the communication being everything. But there's a problem with this, is if you have a very big enterprise company, that means that you have a lot of people around you. And your org chart can be very big and it can be very flat, but you still have a problem. So if you lose some communication bandwidth, it doesn't mean that it's per se bad. So let's go on. Who is old enough to recognize this guy? Come on. And what was the guy saying here? Exactly. So I'm going to do a change on this. This is me, and I'm going to say communication, 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 or in this case, C4 architecture. I don't know if everybody gets, yeah, there are a couple of people recognizing it. Yeah, I should really take a picture like that. Yeah, come on. Okay, so how can we deal with Conway's Law? The first thing is what we're all doing, right? I mean, a lot of people, and you guys actually know Conway's Law, but I've been to places where if I start talking about it, it's like, who are you talking about? Yeah, some guy from the 70s or the 80s that he wrote this. It's like, what has that to do with anything? So they ignore it. The second thing is that what you did now is accept it. Accepting it doesn't mean that you're dealing with it, but at least you know it, and you can try maybe steering a bit with it. Because that's eventually what you want to do. You want to use it, or use the knowledge that you have. So let's look a little bit at the old way. I've been going on along in software engineering. I'm a platform engineer now, but I used to do a lot of software engineering. So this is how it used to look like, right? You have a front end, you have a back end, and then you had one database administrator and one ops that supports that. It's really like a very complicated line, and it's very inflexible. And it's like, oh, look, I have my software, and I throw it over the wall, and then, hey, right? That's how we deploy things. So it would look like this. You have a UI, you have an API, and then you have a database talking to it, and some ops people in the back doing some other stuff. So how can you solve this? And this is probably one of the most difficult things to do, and to be honest, I haven't seen anybody successfully doing this. The inverse Conway maneuver. So what you do is you actually use the knowledge that you have, and you try to build the organization how you want your architecture to look like. So the architecture is supporting the teams instead of bothering them. You design everything to the deployment, and you let it go through and fall with that. And then you have high bandwidth communication between the teams that you have. But again, very difficult, and it's probably impossible because in a large enterprise, are you going to talk to your manager and tell them like, okay, can we disband this team, put it there, and then put another team here? It's like, yeah, not going to happen. But yeah, software engineering continued on, right? And then we started separating things, and we started having teams that actually could achieve more together. Because if you want to reduce the bandwidth, you have to have the teams talking to each other or actually in the same team. It's like the DevOps methodology implementing these kind of things. So here you see that Team A has all of these people inside of it, Team B and Team C as well. So this has a boundary in it. Yeah, this is a bounded context. I will get back to that later. But this is, like I said, the DevOps methodology. I don't know if anybody has seen me before on stage, but I will put this slide in here. Does anybody? I know there's one guy out there who saw it, but let's see if somebody reacts. No, that's a shame. This is a quick reference. On the 3rd of July, I will be giving this talk as well. So if you want to come join me there. DevOps is a methodology, not a role. T-shirt pending. So this is how the microservices will look like, and everything is aligned with each other, and the teams actually have full control over it. So what do we have is that an org chart needs to be flexible, which is difficult, but you need to help or design or get some people working with it. Because if you change the org chart, you change the way that your architecture look like. You can have architects inside of your team, but as long as you have the same barriers that's there, that means that it's always going to be blocking or creating these gaps in your architecture. And this doesn't only count for just software. So Conway actually first started off with processes inside of a company, and later on he started looking for the methodologies inside of software because it was really relevant inside of it. So I will leave this out here. I hope you can read it. I will have a quick glass of water, because this really sums up what I've been trying to say. And gives me some time to wet my dry mouth. So, what can we do to solve this problem? Because this is not solving. Just knowing that Conway's Law is out there and you can do an inverse Conway maneuver, it doesn't solve anything. It doesn't go forward. We need some handholds to continue. And to give you some handholds, we have this nice blue book, very thick, a lot of information in it, and I'm not going to bother you with all of the concepts out of it, but I'm going to try and highlight the stuff that you need to know. And I'm going to do that based on real-life examples, not that I've been through, but just to give an idea of what domain-driven design is. So in this case, what you can probably read now is that the structure and the language of code needs to reflect the business, because you're doing business, right? You're trying to build an app or build something that you need to deploy, use inside of a company. So domain-driven design has a lot of stuff going on. I already heard event storming at a different talk. This is so much stuff, and I would highly recommend reading it, but it is difficult to implement. So you should go on about it by covering the high level of it. And the first and most important part is to define your company. So if you would define your company, you have to go through real-life examples of what you have and write those things down and go through it. But to give an example of what the problem can be inside of a company, I have some examples. So as a support team, you might have you raise a ticket, so you put a Jira ticket or something else in there. You log into with an account, and then you have another team there, and that team has to buy a ticket. It has to buy a ticket, and then they pay with an account, and then they go to a platform for the train. I'm using the train as an example here. So if you see here, the problem is that you see lots of words, and some of the words correspond, or they look alike, or this is not right. Because if I talk about logging into an account and somebody else is talking about, you're paying with an account, those are two completely different things. So you need to have a reflection of these things, and you need to separate these things out. So going even further, if we look at the physical train, and then we're going outside of software, it's like you have three platforms. Platform 1, platform 2, platform 3. And then every platform has maybe a toilet, or a shopping bit, or maybe a coffee place. And if you go even further in it, sometimes in real life they call the whole thing a platform. So how are you going to implement this? How am I going to structure this so that it will really reflect on what my code will actually look like? So going with the train example, we have a train. It arrives at a platform, and it has a destination, and we have a passenger that is buying a ticket that has a price. So then we have another part, is that we have a cleaner, for example, that cleans the platforms, or that has a shift, that has some time, and cleans the platform. It cleans maybe the cafe as well that we showed in the previous example, or with the shop. Look, a shop. Okay, so we have a shop where people can actually buy a product which has customers. So if we separate out all of these things, we start looking at, okay, well, this part is actually part of what we like. And then we have that part that's all combined together. And we have this part combined together. So I called them already bounded context, and this is exactly what they are. And the bounded context is actually how you can shape your teams as well. And if you have these bounded contexts, you can start looking at, okay, what overlaps with each other. So a shop in one part is a shop in the other part, so you can connect them with each other. And the same thing goes with the customer and the passenger. These two are also the same, but they have a different name. So if we look at the whole taken as a thing, then they have certain names for it. So this is the core. This is where you should focus all of your attention, and you should put your developers on and try to develop all of it. If you go to the supporting part, this is where you probably buy some couple of things and you put them there, and you build around it. And there are also stuff around there that you can just completely outsource and ignore. And by beginning domain-driven design, you can actually do an event storming to actually define all of these stuff. And if you define all of them, it's basically writing a lot of stuff on stickies, and you combine them together to each other, and you get to this kind of conclusion. You can see which domains can exist inside of your company. So, that I guess it wants me to be finished. So now I'm going to come to the last thing. Finally, if we combine everything, we have the solution. Yeah, where 50 people plan what 5 people will do the work. This is it. No? No? No, yeah, okay, let's not do it. No, save is not the answer, people. Please don't. So, mashing it up. We've learned about Conway's Law. We've learned about the C4 architecture. No, not that one. This one. And we learned about domain-driven design. And then we can combine everything together. And like I already said, with the inverse Conway maneuver, it is very difficult to build up. First off, you really need to have a base on where you want to go. You need to design the org chart and how you want to do it. And the ultimate goal is, of course, communication. Because if you don't communicate with each other, you can't build anything. Right? I mean, there will always be weird jumps in between or no stuff happening because one people put a ticket there and another one put it there. So you want to be resilient for the future. If you want to have your org chart changed, if you want to do this, you want to be resilient. So how can you do that? You can start combining more types of people inside of one team. So in this case, it says biz, dev, sec, ops. It's just a nice runny word of it. But what it comes down to is the team needs to run by itself. And the team needs to be able to do its own domain and do parts inside of it so that they know where they're going. Yeah, the cons are pretty obvious. I mean, we're all developers. We're bottom up and not top down. And usually the org chart is designed top down. So then we have domain-driven design. So this thing you can always do. Even if you don't want to change your org chart or anything, it is good to know how your product looks like and what stuff belongs to each other and how you can communicate. How often is it that a product owner comes to you and he comes with terms from the business and says, yeah, I want this, that, and that. And then the developers are looking like, oh yeah, we called it like this in the code. Let me change it like that. And if you're not talking all the same language, you will have a lot of difficulties, and you will have a lot of difficulties looking at the code as well. So the unified language part of it. This is, however, difficult to start. There are probably companies out there that will help you with it, but it's definitely worth it. So if you look at it, did I do something like this? To be honest, I tried to when I started at RTL. Yes, from the previous previous talk. I tried starting at RTL with the domain-driven design and implementing it, and they said no. Now, one of the lead developers came to me after I left RTL, and he came to me, we're finally doing domain-driven design. I really wanted to experience in doing that stuff. But we did try to implement or work with it. So we tried pushing the teams into their domain, giving them Terraform repositories or platform stuff to actually achieve this domain part. So this was it. This was me. I hope you enjoyed it. And there's one more law left. It's Postel's law. Be conservative in what you send and be liberal in what you accept. In other words, questions?